Alright, welcome back to assignment 1.4. Alright, we're continuing our expressions and assignment statements, but now we get to talk about compatibility, constants, arithmetic operations, precedence, and integer floating point division. So, this is the section for those of you that are like, ugh, I don't like math. Well, the math's coming. So let's get started. Recall that we have talked about what a variable is in programming. Int number is an example of a variable with its type. Int number, it's just the type. Now, we can only store a variable as a single type. So, for example, int will always be integers, right? Just like double will always be decimals. So let's look at an example here. It says int variable. Int variable equals 2.99. Now, if you remember integers represent positive or negative whole numbers. If I look at 2.99, that is not an integer. It's actually an example of a double, or float if you want to go that route. This would actually throw a type mismatch here because you're trying to say, hey, I want to put a double as an integer, and the program's going to say, I can't do that. Now there are some exceptions. Right? You can take an integer and assign it to a double. So you can just say like 1, like if you had like double variable equals 1, that's okay. Even though 1 is not decimal, 1 could be converted over. And Java will automatically do that. It'll change it from 1 to 1.0. Assignment compatibility. All right. So let's look at assigning an integer to a double. So in this example, I have double variable equals 2. All right. So this is kind of like that example I just kind of talked about where we want to change that over. We can also assign variables of integer type to double. So here I have int variable equals 42. Double variable and double variable is equal to the int variable. What would be the value of double variable right now? The value of double variable would be 42. Because again, doubles can take ints, just int can't take double. All right. This is what's known as typecasting, or changing the type of the variable. We're going to explore this a little bit more later. Let's continue talking about assigning values. You can assign a value of any type in the following list to a variable of any type that appears further down the list. So you have byte, short, int, long, float, double, which means, for example, I can take a int and assign it to a double. I can take a int, assign it to a long. I can take a long, assign it to a float, so on and so forth. As long as it goes down that list, I can assign something above it. Literals and constants. Right? Constants or literals, the terms are kind of interchangeable, just means specific values. Whereas variables can change, because I can give it a new value, like x equals 3, and then I can either say x equals 4. Constants do not change. Right? We also have to deal with scientific notation. These are very large, very small numbers that can be written in Java using scientific or floating point notation. Note that the following numbers are all either float or double. So here I have 3.67 times 10 to the power of 5th, or I have 367,000.0. Right, if I want to write that out using scientific notation, it's going to say 3.67 E5. The E stands for exponent and means to multiply to the power that follows. Right? So it's just 10 to the power of 5. All right, let's talk about quotes, particularly in strings and chars. All right, char represents constants here. All right, it's a single quote. So, for example, char letter equals A. We just use a single quote on it. A string is double quotes. System.out.println, welcome to Java. Right. Anytime you see a single quote, that's a char, double quote, it's a string. And then we have also Boolean constants to talk about. There's only two things to really worry about in Java with Booleans, is that they're either true or they're false. However, when we're making a Boolean constant, they have to be all lowercase. Right. We're not going to use uppercase, camel case, they're just lowercase. Let's get into some arithmetic operators. In Java, you can add, subtract, multiply, divide, and use the modulus or the remainder operators. That's that percent sign. If both numbers are of type int, then the answer will be of type int. However, if one or both are of type double, then the answer you should expect to be double. Precedence rules. Right? Much like orders of operations in math, Java has a set of rules that it follows. The highest precedence is the plus plus or increment operator, minus minus, which is the decrement operator, exclamation point, which you could say, hey, that's factorial. It also means not, and when we get into some other stuff. Parentheses, medium precedence, which means this is the next tier down, so multiplication, division, and the modules operator. And lowest precedence is simply just addition or subtraction. Now, we have to talk about integer and floating point division. In math, I can do 10 divided by 3 and get an answer of 3 1/3. However, if I try doing that with two ints, I'm going to get an answer of 3 1/3. We're not going to get that. I expect 3 1/3, but I'm actually going to get 3 as an answer. Right? And this can be a very confusing point for students because the answer is not rounded. It's not rounding. It's truncating, which is a very different thing than rounding. Truncating. So everything after that decimal point is ignored. So even though it's 3.3333333 repeating, anything after that point, that decimal point, is ignored. It truncates it off. If I want a decimal answer, I'm going to use double or float. So I'd have to use like double and then do 10 divided by 3. Now we can use the modules operator to find a remainder. So if I do 14 divided by 3, I'm going to get the whole number part. So if I do 14 mod 3, right, I'm going to give you the remainder. So if I do 14 mod 3, I can say, hey, it's 14, and then it's a remainder of 2, because 14 mod 3 would say 2. So let's talk a little bit about the modules operator. Just thinking back to the old days of learning division, right, when you had to calculate remainder. Remember, we had to do long division. The modulus operator does just that. It finds the remainder. So in the quick example here, this is pulled right from our previous page, 14 mod 3 equals 2. This is because 3 will go into 14 4 times with a remainder of 2. I'm not interested in the 4. I can just do 14 divided by 3 to get the 4. But if I want the remainder, I need to know what that is. You can use modulus to count by 2s, 3s, or any other number. You just can't really do 1. I mean, you could have a remainder of 1, but it's a good way to kind of break things up, because anything divided by 1 is itself. Alright, here's your self-test questions, folks. So let's go ahead and look at number 1 here. What is the output of the following lines of code? Double number equals 1/3 times 3. System.out.println, quote, 1/3 times 3 is equal to, quote, plus number. Number 2. What is the output produced by the following lines of code? Int quotient, remainder, quotient equals 7 divided by 3. Remainder equals 7 mod 3. System.out.println, quote, quotient equals, quote, plus quotient. System.out.println, quote, remainder equals, quote, plus remainder. Number 3. What is the output produced by the following lines of code? Int result equals 11. Result equals result divided by 2. System.out.println, quote, result is, quote, plus result. And that concludes this lesson, ladies and gentlemen. I know it might be a lot of this stuff, and you're like, oh, so much math, but, pretty soon there's not going to be so much math, and it's just going to be more logic-based stuff where we're actually going to do some problem solving. So, until next time.